All right, I'm going to walk us into the controls engineering lab here. One of the first things that you're going to see in our controls engineering lab is our Emerson process controls tanks here. So this is a project that our students work on in multiple semesters. It's a big piece of it's been a big piece of our capstone project, capstone projects over the past couple of years as well. As you look here, what you're going to see is there are two control panels in here, and in these control panels, the students have installed PowerFlex 525 VFDs, a control transformer, DC power supply, a contactor for a heater, and down in the bottom here we have an Allen Bradley L18 ERM PLC. This is the PLC that's the controller for the whole system. We also have a Maple Systems headless HMI and an industrial network switch. And what we're using this system for, I'm going to go ahead and hit start here real quick, is down on the bottom down here we have two pumps, a pump back here and a pump on the right. These pumps are being controlled by the VFD, and they're moving water from tank to tank. So right now we're going to move water over to tank 1. It's hit its limit, and it's going to start pumping water back to tank 2 right now. So you'll see water coming over to tank 2. Now the neat thing about this is the screen, the HMI screen that we built in this lab actually is connected to all of our instruments on the tanks via that programmable logic controller in the control panel. So as an example, you'll see an Emerson, you can step back a little bit, Emerson discrete level control. So this is just a level switch that our tanks, we can tell when they're full. We have an Emerson Rosemount radar level sensor. So this actually uses a probe within the tank that we can calibrate to a 4 to 20 milliamp signal that comes back to the PLC. Then we can display the data up on the screen up there. We have a heater here. This heater actually allows us to heat the tank. We don't currently have any way to cool, but they cool pretty quickly because they are a big heat sink by themselves. Then we have a number of instruments that include things like DP flow. So we take a differential pressure across the restricting orifice, and then we can calculate the flow of the fluid through this system here. And then on the bottom here, we also have a temperature sensor. You can actually see the temperature right now at 71.5 degrees Fahrenheit. All of this data is being communicated via 4 to 20 milliamp signals and heart signals back to our PLC inside the control panel. On this side, on tank 1, we have a very similar setup. We have a discrete level sensor. This is just to verify that we don't get any overflow. We can shut the pump down in case there's ever overflow. And then on the bottom here, we've incorporated another instrument, which is our DP level. So we basically take atmospheric pressure on one input, and then the tank pressure on the other input to read the differential pressure to determine the level of the tank. And then the great thing about all of this is our pseudo SCADA system here that we're using, which is basically a headless HMI. And this headless HMI, we can actually monitor things like temperature, level. You can see the level of tank 2 is coming up right now, has a target level of 32. You can see tank 2 flow rate is about to change. So tank 2 flow rate's coming off that DP flow sensor right now, and it's sending water across from tank 2 to tank 1. So maybe we can just watch it fill up the tanks. So this has been a great collaborative project that we've had 3 different capstone students groups work on. So more than 20 of our automation controls engineering technology students have worked on this project, and it's included the piping, the wiring of the instrumentation, the programming of the PLC, the commissioning of the drives, the plumbing of the pumps, the instrumentation commissioning. We've worked with engineers from Emerson, we've worked with our faculty obviously, and then a whole bunch of our students, and they've gone so far as to create a whole set of prints that you see here using ECAD drawings for the entire system. And we actually use this a little bit in a couple different courses. So our electrical CAD students will get exposed to this during the ECAD course. So it'll be one of their first exposures to a real-world system, real-world wiring using ECAD. And then we also do some P&ID drawing work up here. So we actually can see the different control loops. And what you're seeing right now up here is actually our current capstone students starting to lay out what they want to do with this system, which includes networking 24 PLCs across the room, installing some new instrumentation, and creating a SCADA system interface within Aviva Wonderware. And then also trying to create an add-on instruction that the new automation and controls engineering technology students can use when they're in their introductory PLC courses. So this is the Emerson Process Controls Lab.